Thank you. So good morning, everybody. Thanks for being here. I've done presentations for this event for several years now, and I always enjoy doing it. It's great to interact with folks that are interested in these things, especially here in the state of New Mexico. Basically, the point of my presentation today is just to let you know about a resource that is here in New Mexico that can be a source of information and also testing capabilities and other technical support capabilities if you need it. So I'm going to get into it right away here. So this is to tell you briefly about the White Sands Test Facility, and this is our mission statement. As you can see, it's about testing and doing things to support NASA programs, and in these days also other government agencies and commercial entities, which I'll get to here shortly. Just to give you an idea, the NASA White Sands Test Facility has been here for a long time, since the early 60s. A lot of people are still not aware of it, but we don't have a public visitor center or something like that for people to come to, so we're not that well known. We're not trying to be a secret, it's just that's the way it's worked out. So that's one of the reasons I'm out here doing things like this, to try to let people know we're there and want to be a part of the aerospace community in New Mexico and help grow the economy around aerospace, and also help our fellow enterprises here in the state. Customer base, just to give you a sampling, of course, the main reason that we're here is to support NASA programs, particular things like the International Space Station, and in more recent years, the Orion crew module, the Space Launch System, and commercial crew programs. We've been doing testing and support, evaluation support for all these. Also various other government agencies that you can see listed here. And then the commercial base is, we've been doing work for commercial companies for decades, but it's certainly stepped up in the last 5 or 6 years. This gives you an idea of some of the companies we've done work for. This gives you an idea of the kind of things that we've done on the International Space Station. We have, since it was being developed, done support, and we have the ability with the various functions that we have. A lot of them are flight rated, which means we can design, develop, assemble, test, refurbish things that are flight rated, space flight rated, which, as all of you know, takes a lot more rigor in your processes and how you do things. So we're able to do that. This gives you an idea of what we've been doing for the Orion program, testing materials and doing engine testing. So the Orion capsule has a service module underneath with small thrusters. We've actually refurbished some of those thrusters from the shuttle era and used them in testing for prototypes for the Orion vehicle. Space Launch System, we have rocket engine test stands, which I'll talk more about in a minute. They are not capable of taking the giant booster engines, but for the upper stages, we are able to test the engines that go for the upper stages, like, as I mentioned, the Orion crew capsule. It has its own small engines underneath it that are used for maneuvering in orbit. Out of all the things that we do, some years back, we decided we need to figure out what we wanted to advertise as our core capabilities, and make sure we focused on those. So this gives you an idea of what those are. I'm going to go through those quickly as we go through the rest of the slides, but this gives you an idea of the range of things. The rocket propulsion testing at the top was the main thing that the White Sands Test Facility was built for back in the early 60s. And all the other things you see here have gone along with aerospace testing, a lot of it related to rocket propulsion testing, some of it different. So I just want to say a few words overall about innovation. When I was putting this together, I thought about our innovative activities. So like a lot of technical organizations, I feel like innovation is it's embedded in our culture. It's part of what we do every day. And for us, most of our innovations have to do with improving or modifying or our testing capabilities, or coming up with new ways of testing things that are better or accommodate a new technology or things that are coming along. And our drivers, like similar to a lot of other people, are customer test requirements as they evolve and change, and then new programs and new technologies drive us to come up with new, better, or different ways of testing or testing different things. So just a bit about our rocket propulsion testing. This gives you some photos of a few different tests going on. Again, we test the smaller engines that are on upper stages of vehicles, and we not long ago we were testing the upper stage rocket engines for the Boeing CST-100 Starliner service module, in one test stand, and we had the NASA Orion vehicle testing the engines for that in the test stand right next to it at the same time, which was very cool for us. So I want to get into a couple of different things that we're doing, developing this innovations. We know that CubeSats and other small satellites are becoming a big part of the aerospace and the spaceflight industry. So a few years ago, we got the idea to develop a test bed. We have these large vacuum chambers at our place that we use to test rocket engines in. And we had one that was not being used for a while, so we started developing a place that people could bring CubeSats with their small propulsion systems, their control systems, and so forth, and test them in a vacuum in a frictionless or near frictionless environment on a table, so that they can test out the functions and the operation and further develop their capabilities. This is a few shots of different things we did as part of this. This is mainly, what you see here is mainly about developing a frictionless system that worked to the degree that we want it to. Another thing we do a lot with is composite pressure vessels. Those are used for all kinds of fluids, gases, liquids in spacecraft, and they are much lighter and stronger, of course, than the traditional steel tanks that would be used for those kinds of things. But they have their own set of things that have to be dealt with, and they're constantly being updated and new designs coming out. So we're always testing these things. We don't build any of these, but we do test them in lots of different ways. Burst test, the strand test, and so forth, to let companies that are developing or using these COPVs understand how they're functioning, what their limits are, and so forth, so they can keep improving them. And we also teach, we've developed and taught and do teach courses on how to do damage detection on these things. This is kind of an eye chart, but just to give you an idea of some other things we're doing, other areas we're innovating in. COPV scanner to look for flaws, impact detection system, strength, a new way of doing strain measurement, and things like that. Again, testing and evaluation is the theme here. So in COPVs, which a lot of this is about, they have less structural margin compared to others, certainly than steel tanks and even COPVs used for terrestrial applications. So they're great. They're necessary for spaceflight to do what it does, but they do have their own set of issues we have to deal with, and that's what we've focused on. This is just a little bit about how the fact that we align with NASA's agency priorities. Fortunately, a lot of what we do is also very useful to other government agencies and commercial space companies, so that allows us to do work for a lot of customers. This just gives you another quick thing, a pneumatic burst test going from upper left to lower right. You see it progress through failing intentionally to see what happens when it failed. This just gives you some of our capabilities that are unique to the White Sands test facility. Again, things, particularly in measurement and inspection, things that are unique to WSTF. And here's some other examples of things. So there's the safer unit that astronauts have used for years to move around when they're out in space. We are doing work on those to upgrade them and extend the life of them. We recently helped with with detecting an air leak in the space station that was getting worse and worse, and supported an effort to find out where the leak was so they could deal with it. Here's another example of testing where we've got 30 different COPVs with doing a burst test on them. So if you have a bunch of them and you do this testing on, you get a more representative sample of what you're going to see out in the production environment and ones that are actually being used for operations. Some more examples of things that we're doing in non-destructive testing in other areas. This is an example of, we do spaceflight component services. As I mentioned, we can assemble, test, repair, refurbish spaceflight things, including small rocket engines. We have a whole array of technical services that support the testing and evaluation that we do. All these things are flight rated, as I mentioned, flight machining, welding, valve repair, things like that. This just gives you a representative list of the test facilities that we have. A number of different test facilities that have been built up over the years in response to needs for testing. And this is my last slide. This is training courses. This is one of the things that in particular we offer the space community, all this expertise that we have developed over decades. We offer this training to both the NASA programs, the NASA centers, but to other government agencies and to commercial companies. We do this testing both at our site and at customer sites. And that's it for my presentation.
All right. Thank you, Joe. How can people get in touch with you if they're interested in connecting to some of these trainings, some of the facilities? What's the best way to connect with Jacobs with NASA?
Thank you for that. I think my information may be associated with the event here, but I'll give you my email. It's simple. It's just joe.bullington@nasa.gov.
All right, that's easy. And with that, Frank, Avinash, I will hand it over to you guys. We've got a couple minutes here.
You know, we do see, hold on a sec, we do see surprisingly a surprising number of business plans these days for folks trying to do things. So if you could send me your presentation, that would be helpful, I think. One question I have is, you know, some of the things we see are cube and microsatellites. Do you have any platforms that you offer to startups? I mean, if you think of a 3U satellite, 1U is typically power generation and power distribution and management, and one is sort of comms and stabilization and all those things. And then the last U is the actual payload. It's whatever sensing and so on you're going to do. It would be nice for these little companies if they could just focus on the 1U, and the other 2U they buy. They know that it has these parameters. It's spec to do this. It's flown many times and so on. Are you a contact for things like that?
We don't directly deal with that very much. We're trying to offer a way for for the small CubeSats to be tested once they're ready to go. I certainly have contacts within NASA. If somebody's struggling to find what they need, I could certainly reach out to my NASA colleagues and others. I'll be happy to do that.
Okay.
To look for the things you're talking about.
Another question, do you ever use your location to test the limits of what I will say are non-space systems? I mean, I guess compression, composite pressure vessels are an example, because they could be used here on Earth for high pressure natural gas or whatever. Yeah. We have a company that does flywheels for energy storage. And as you know, the big one of that, you may not know, but the big problem with flywheels is if you have an instantaneous shutdown of the thing, you're releasing an awful lot of energy very quickly in the form of kinetic energy. But it would be like blowing up a pressure vessel in some ways. So it may be another ways that you guys could be. Would that sound like something they could contact you about? Or? I
would think so. I don't see why we couldn't do that. We do other kinds of testing. Well, things that are hazardous or can blow up. We actually have a big wide open area where we can test something to failure or something we're concerned it might fail explosively.
And you have really high speed. You have really high speed cameras so that you can watch the failure event and so on like that.
Yeah, we have cameras that some that go up to tens of thousands of frames a second, and we have some other ones that go up to in the millions of frames per second.
Wow. Okay. Avinash, do you have any more questions? I take it this is we're not letting these little companies have to compete against White Sands, right? For their
no, we're hoping to help out the small companies.
Okay, yeah,
support them.
Actually, I was thinking in the similar lines, but my question would be more like, so is this facility equipped for when you say composite testing, we are talking typically carbon fiber composites, or also even metallic and other sorts of composites?
Yeah, it's primarily. Pretty much it's limited to the composite over at pressure vessels, where you have a very thin metal liner and then you have the wrap, the composite fiber wrap over it. I'm sure that our experts that are there have some knowledge of other kinds of composite, but it's mostly those kinds of pressure vessels.
One more question on the really small engines these days that are using xenon gas, and they're electromagnetic. I'm not explaining them very well, but they're charged particle. Can your test facility in the vacuum on the maglev test these extremely low force, but engines that run for weeks at a time type of thing? Can they test things like that as well? Is that the purpose of that?
That's a very good question. I don't think anybody's approached us about that, but I don't know any reason why we couldn't. Either in that facility that I showed you the slides of, or other facilities, we should be able to do that.
Okay.
And then the next question would be more like in terms of the testing kinds, like you do like shear or fracture or even fatigue kind of testing, or?
We do that on materials. Yes, we do. We have a variety of different materials tests that we do. We also test components. That's one of the things I didn't go into a lot, but valves, regulators, flex hoses, all kinds of components that go into aerospace fluid systems. We test those. We also do testing on the materials that goes into various aerospace products.
All right.
Okay, perfect. Thanks.